Storage Part 4. In this nugget, we'll clean up our last bits of storage topics here by talking about Storage Part 4 troubleshooting, where we'll take a look at some of the key troubleshooting items that you might have to address with storage. And then we'll take a look at backup, which is a bigger topic, actually, and covers quite a lot of different types of backup as well. Now let's also talk here about troubleshooting storage. Now, for a lot of troubleshooting in all of the various topics we've discussed so far, much of the troubleshooting is really making sure that what I've told you to do in terms of installation or configuration has been done properly in the first place. Much of the time, if you look at a device or a troubleshooting problem you're experiencing, you'll find that it was not configured or installed properly in the first place. By reinstalling or reconfiguring it in the way it should be done, you've just solved your troubleshooting problem. However, there are also some troubleshooting things specific to storage that I do want to address on their own, and we'll probably also have a troubleshooting section at a later time to address some of the other kinds of hardware and the like. But for the hard disk drive itself, there's a couple of different types we've talked about, parallel ATA, serial ATA. In terms of the platters and all of that, the internals of them, they're both the same. They just have different controllers and interfaces. There's also SCSI disks, I guess I could have put on there as well. But for those types of things, one of the common problems you might run into is some kind of a file corruption. And if that's the case, you might have a corrupt cluster on the hard drive. In order to help resolve that, what you want to do is to take any data that was in that cluster and restore it from a backup if you have it. Otherwise, that data might be lost for good. And then the other thing you might consider doing is you might consider running check disk. Now, this does not repair the cluster. Usually that's a physical defect or damage of some type that can't usually be recovered, but you want to mark it as bad so that it can't be used in the future to store any additional data. Now, what I'm doing here is I'm running check disk against drive F, and then I'm in Windows XP, but it works across all Windows operating systems right now. And then a /F is the key there. What that does, it's going to check for any of the damaged clusters, and it will then mark them as unusable. And then when you press enter, it'll tell you whether or not you have any bad sectors, and it would show up right there. It would also show you any other problems you had with specific files that might have been cross-linked or otherwise had some kind of a problem. And then switching over here to Windows Vista, I just want to point out that here I can go to the properties of a drive as well. And from the Tools tab, I can also click Check Now, which will automatically attempt to fix the file system errors if I have any. But then, equivalent to the /F, I could scan for and attempt recovery of bad sectors. Now, you can also do that from a command line. Notice that if I'm on drive C right now, and if I don't specify a drive letter, then it will attempt to check disk against drive C. In fact, though, it can't really do that right now because it's in use by the operating system, and if I press enter, it'll tell me as much. What will then happen is it'll ask me if I want to check it the next time the system restarts, and because it will then be able to check it against the drive before the operating system loads. That's why that happens. The way it does that, by the way, is that when I say yes here and press enter, it will mark that drive with what we call a dirty bit. So then when the system starts up, the hard drive says, "I'm a dirty bit. I should be scanned." Wow, that sounded even worse than it was in my head. So anyway, you get the idea there, though. That's kind of the way that whole thing works. So in addition to the check disk command, also check for smart monitoring. This is something that's usually turned on in the BIOS, and you may also need to have a software piece that will correspond to smart. So it'll be able to communicate with the BIOS or with the controller, and the software will be able to see if the controller identifies any recurrent errors on the hard drive, and it will then say that a specific drive might be at risk of failure. If you want to anticipate that it could fail and you can afford it, you might just want to replace that drive in advance before an actual failure does occur. And then there's also a solid state drive. For this, mostly it's going to be similar, although some of the tools aren't quite the same. For example, the disk defragmenter. For this, you definitely need Executive Software's version because it's capable of working with solid-state drives, whereas the built-in version of Windows is not able to arrange the data properly on solid-state. Because remember, with solid-state, the data is stored in the kind of those modules. It's not really stored in sectors on a disk and on platters the way physical hard disks are. But you can still also run check disk against this if you need to. For floppy disks, again, remember if the light stays on, it's probably because the cable was installed upside down, so you need to just reverse that, and that will happen if the hard drive light is, or the floppy light is on and it stays on even if there's no drive or no floppy in the drive. Another thing you can do with floppy and optical drives like CD and DVD ROMs and burners is that there are cleaning supplies you can buy for those, and they're usually the same shape as the disk, and you just put them in the tray. You may also need to squirt some kind of an alcohol material on them, and it will clean the heads on a floppy disk, and you can also use those to clean an optical drive. Although for either one of these, if the problem is anything beyond a very simple and inexpensive cleaning kit, then you probably just need to replace them. They're both very cheap, and they're really not worth the trouble to go through extensive troubleshooting. For removable or external hard drives, very often the problem that you'll run into there is that you'll plug one in, and let's say that it's normally identified as drive G and with a label and everything, quite easy to work with and view the files, but sometimes it'll just plug in and you'll look in Windows Explorer and it'll just say removable storage without a drive letter. Sometimes plug and play kind of has a little hiccup and it may not have properly recognized that device. What I would usually do is, if I have any problems with that, or if it doesn't seem to recognize it at all, and I know it did in the past, I'll usually just unplug those, wait a couple of moments, and then plug it back in and see if plug and play was able to resolve that item. Another thing I might do, and let me just show you here off screen here. I'm opening something up here. Let me just bring it in. I can also go into Device Manager. I'm doing this for my Windows 7 machine, which is not on the A+ exam, but this interface is pretty much identical. I could go into this as well, and if I've got a drive that's attached but it's not showing up, I can right-click here and scan for hardware changes. And very often at that point, it will then pick up any of the additional devices that it was not able to pick up earlier for some reason or the other. And then when it comes to storage controllers themselves, one thing to look at there, if it's like a RAID controller or a SATA controller or even one of those that has eSATA on it, if it's not able to recognize any of the drives that are connected to it, if there are multiple drives, then very likely it is a problem with the storage controller itself. Otherwise, check the physical connections. That's a basic tenet for across all of these troubleshooting topics, by the way, across all of this, is that if a drive doesn't seem to be behaving properly, make sure that the connector is firmly inserted into the device or into the controller or into the motherboard, whatever, especially with serial ATAs that don't lock into place. They come loose all the time. So check for those. And then, provided everything is inserted properly, the other thing I would check for on storage controllers is to make sure that you have it properly configured in its own internal BIOS. So remember, there's multiple ways to access those. On mine, I press Control-I, some are Control-A, some are Control-S. And then the other thing would be, it might be a bad controller, just as simple as that. If you have another one that's the same kind of controller, then you can plug that into the computer instead and see if it operates properly. And if it does, then probably the original controller was bad. And then finally, also check against things like drivers. Sometimes there may just be an updated driver. And this also applies across virtually all Windows components that are plug and play. If a device does not seem to be operating properly, check for the latest drivers, especially for things like storage controllers, or video is also a very common one where you have to update to more recent drivers to be able to get the best performance and reliability out of that particular device. Now, I mentioned earlier that you will have to have a backup of your data sometimes. For example, if data gets caught in a bad cluster, hopefully you've got a backup where you can restore that data. One of the key ways that backups are made, at least according to A+ exam objectives, is tape drives. Although, be honest, I'm a little bit surprised to see tape drives on the A+ exam. This is really something that belongs on the Server Plus exam. Hardly any consumers will have a tape drive. You'll see this more likely in businesses like up to a medium or even large businesses. Larger businesses, though, will have tape libraries and autoloaders and kind of a robotic system which swaps the tapes out and schedules them and does all the maintenance for that. These tapes will even have barcodes on them so that there's a built-in barcode scanner in some of these drives which can identify specifically which tape it is and when the backup was made and all that type of thing. But for the consumer level, if there is such a thing for tape drives, there's a myriad of tape types. These are just cartridges that will have tape in them, just like the old cassette tapes that we used to have. Similar kind of a media and substrate. With these, you can have a Traven format, a 1/4-inch cartridge, or quick linear tape open, or LTO. This is very popular these days. There's some new ones coming out there, but these are capable of somewhere in the gigabyte range, depending upon compression. And then you'll also have digital linear tape. So some of these, like I said, with LTO, can support storage depending on the cartridge that you're using, and whether it's LTO4, LTO5, or whichever standard, upwards of a terabyte actually. So these can get to be quite large, but some of these older ones might only store a few megabytes on them, 20 megabytes, 40 megabytes, something like that. And if that's the case, you may have to swap those out. Anyway, how do you connect these tape drives? Well, there's a number of interfaces. You can use parallel ATA or serial ATA. There's also SCSI. I should go out of order a little bit there. But SCSI is also a common way to connect. In fact, for businesses, you're more likely to use SCSI. For individual tape drives on maybe a power user side of things, probably going to be parallel or serial ATA. And then some of the older tape drives that actually connect through the floppy drive connector. Oh, wow. That's slow. Anyway, we also will have USB drives that could be used, kind of like an external tape drive that's on a USB or FireWire or eSATA. eSATA is kind of my preferred method as a good balance between inexpensive and good performance. I also mentioned earlier that the A+ focus is generally going to be on single drives, as it should be, even though most users will not have any tape drive at all. One key thing to keep in mind with tape drives, though, is that it has a relatively long backup window. I don't use tape drives anymore because hard drives are so large and relatively inexpensive, and they're also substantially faster than tape. But when I did used to back up to tape, sometimes it would take all night to back up. So the backup window is the length of time where the backup takes place. This gets to be pretty important in business because they might be a business that runs 20 hours a day. Well, your backup window might only be that 4 hours where they're not running. Or if it's a 24-hour operation, then you have to run the backup during production hours, and you have to find out which hours are the least productive so that it interferes with the least. Also, another thing to keep in mind is that conventional backup methods, such as earlier versions of NT Backup, which is Microsoft's version of backup, were not able to back up open files. More recent versions are able to do that through something called the volume shadow copy. But otherwise, NT Backup, as well as many third-party products, would not be able to back up files that were open. And some of the critical files are open all the time. So they would very infrequently get backed up. Now here for your reference, I just wanted to go ahead and grab a picture of a tape backup drive. This one's a full height one, but you can get them in a number of form factors that can be put inside of an external drive bay in your computer, or standalone that sit outside your computer that connect in other ways through, again, SCSI or any other kinds of means. This one is a full height one. It supports Ultrim LTO4 tapes, so that should be good for about 1.6 terabytes compressed. So that's quite a lot of storage that's available there. And then here's an example of one of the tapes that you might see there as well. Those tape drives, those are pretty expensive. That's, again, why you might not see those on conventional users' PCs, because that tape drive is probably between $1,600 and maybe $2,500, depending on the configuration that you get. So pretty expensive. But high reliability and high capacity as well. Now, the way NT Backup, as well as a lot of other traditional backup programs work, is they can run with a full backup, or a differential backup, just kind of abbreviated here as diff, an incremental backup, a copy, or a daily backup. And I'm going to explain all these different things to you. Now, the first thing to understand is, let's say I have a specific file that I care about and I want to back up. For example, a couple of years ago, during the springtime here near my house, I photographed this picture of some saguaro cactuses with some wildflowers down at the bottom of them. We rarely get these blooming wildflowers here in Arizona, even in the springtime. So I wanted to get this picture. It's kind of an important picture to me, and I really liked having it. So once I photographed it and I put it on the drive where it resides, here's the drive where it resides, and here's a number of other photographs that I also took. Here's a wedding that I shot that same year, and some other things that were going on there. What I want to do with this is when I create a full backup, what happens is the full backup will back up all files regardless of whether or not they have a specific bit set that's known as the archive bit, which you can see by going to the properties of a file. And I'm using Windows 7 for this, but it's exactly the same in Vista or XP. And then if you go to Advanced here, you'll see this item. File is ready for archiving. That is the archive bit. So what happens here is once the file gets backed up with a full backup, all the files that it backs up, it clears this archive bit. Now, once that archive bit has been cleared, then what happens on the next time we have a backup? Well, if we have it scheduled, maybe we want a differential backup. That would mean that we want to only back up the files that are new or changed since the last full backup was made. When a file is new or changed, the archive checkbox is automatically reselected. So if I have new or changed files, they'll have that checkbox item, and then on the differential backup, it'll back up any of those files with that archive bit set. Then what the differential does is it clears all those files that it has backed up once again. This helps to conserve a little bit on tape space, or most of this also applies to disk space. So if you wanted to back up to a hard disk instead, this would still apply. But then what would happen here is, if I wanted to restore a file, and let's say that it was a new file made after the full backup, so that that new file would exist on the differential backup that I had, then using NT backup, I would have to supply both the differential backup and the full backup that I had created earlier. Because especially with tape, it has to kind of connect these two. If these were on two different tapes, I would have to start with the differential, and then it would prompt me for the full, even though the data I want is not on the full backup. I'd still have to supply it. And tape drives can be extremely long. It can take a long time to fast forward and rewind and stream all the way through the tape that I need. So this can be a little bit of a time-consuming process. To give it a little bit more clarity with all of these as well, by the way, I've created a PDF file, again available up on nuggetlab.com. And what this is the backup on the archive bit and how all that's handled. So again, for example, a full backup will back up all the files, but clears the archive bit. That way, when the next backup occurs, which might be, for example, a differential backup, since these backup files have been, since these files have had their archive bit cleared, the differential backup will not back them up. And then it will only back up new or changed files since that full backup, because new or changed files will have an archive bit automatically set. As a general rule, differential backups require more storage space than incremental backups, but they are also faster on the restore because you may potentially have only a couple of tapes or fewer tapes if we're thinking about tape. And then for incremental backups, backs up only the files with the archive bit set. And then what it does when it's done doing the backups is it will clear the archive bit of those files that it does back up. The result here is that the incremental backup is generally going to be much smaller than a differential or a full backup. However, on the restore, it could be much more time consuming, again, if you're also only working with single tape drives, because you may have to swap in and out multiple drives. You also have to start with the full you have to have the full backup and all the incremental backup tapes that have been used in that process, so it can be very time consuming. A copy backup will back up all the files but does not clear the archive bit. This might be useful for taking just a copy of all the data off-site for archival storage, or if you just need to have a copy of it elsewhere, for example. And then it does not, like I said, it does not clear that archive bit. And then a daily backup will back up only new or changed files today, but it does not clear the archive bit, and that way it will not interfere with our differential or incremental backups that we may also have going on or scheduled. So by way of example here on Windows XP, if I go to All Programs and then Accessories, and then over here to System Tools, you'll see that there's the backup utility, which starts in Wizard mode, but I can bypass that and go to Advanced mode. In Wizard mode, it's just kind of a next finish wizard like you see here, backup files and settings, and My Documents, in other words, your data files, and your settings, such as operating system settings. Or I could choose all information on this computer, which would be the entire hard drive. Notice that we can also specify everyone's documents and settings instead of just my own. And then you can also selectively choose what to back up, in which case you'll have a chooser like this, where you'll just go through here and you'll say, I want, this file, but not that file, and, so forth. So you can just checkbox the items that you want, for example, here. And then you specify a destination. We don't have a floppy drive, but I think I do have an E drive. Let's see what's on there. Yeah, that's a backup volume that I created especially for that purpose. And then I would just name the backup and click on Next, and then Finish. But I'm pretty well done with that. I'm actually going to cancel that one. If you click on Advanced, this is where you'll see you can specify which of the other types that I've already described you want to choose instead. And then you can also choose to verify the data after backup as well. You can also choose to disable volume shadow copy, which will also, which normally is not a good idea, but it does make a faster backup if you're in a real hurry. Obviously, the disadvantage is if a file is open, then you cannot back it up if you disable volume shadow copy. And then if you have an existing backup that's already in place, like on tape or as a backup file, which are stored as .bkf files, you can append to the existing backups or replace the existing backups. And you can run it now or schedule it for later. And then that's pretty much it for that. I'm going to cancel that and come back into it to show you the other method of running backup. Oh, it's still on my start menu, so I'll just launch it from here and go to advanced mode, where we can choose backup wizard, which is the same wizard I just showed you, restore wizard, which would do just that as well, or an automated system recovery wizard, which would also create a floppy disk which has certain system settings on it and that allows me to recover the entire operating system. I could choose to back up then whatever I'm interested in. I'll just choose all of drive C, and then I'll click on start backup. Notice that it says the backup media or file name. So I've already created a backup on that drive. In fact, if I go to my computer and double click on it, you can see that I've already got a file created there. And then what I would do here is I would just click on Start Backup, but before I do that, I might want to go to Tools and Options and specify that I want this to be a differential or an incremental backup. You know, if I want to exclude certain files like temporary files or the paging file, those sorts of things, you can see that they're already excluded for all users, but I could add in additional files that I want to avoid backing up, for example. So that's pretty much it for that. I could just click OK then, and then start the backup. And after a little while, it will it'll tell me that it has finished the backup. Again, I can append to the existing media that I've already got. In other words, it'll append onto the end of my existing job. There's also a schedule if I want to schedule it to run at a later time. If, for example, the computer is very busy right now and I want to back up during off period. And I can also go back to this advanced item and choose some of the items that I showed you a little bit earlier there as well. So once that's been done, I can then just click on Start Backup. Oops, I guess better click on Start Backup here. And that's pretty much it. Then once this is finished, we'll see that we then have a copy of our data that we can restore from. Now then, once the backup has been made, and we can see one here, then I can restore the data as well. So if I wanted to restore something from my previous backup here, I can just go down here. Let me just go into Windows. Not really thinking of anything in particular to restore, but let's just say it's this, whatever this gone fishing bitmap is. Okay, maybe that had gotten deleted sometime. Well, I could start the restore to the original location, or an alternate location, or a single folder as well. Here it says if files already exist, do not replace, but maybe it's a bad version of the file, and if that's the case, then I might want to go to Options, and on Restore, I might choose to replace the file only when it is on the file on disk is older, or always replace the file on my computer. And then I could start the restore, and I could click OK. And I have additional options if I want to choose Advanced. Okay, but I can just choose OK here, and then it just mounts the media, and it will restore that 1 bitmap file. And there it is. Okay, so now it restores it. It tells me kind of a summary of what it did. It restored a single file there, and that's pretty much it. Okay, so just close that up, and I would have that file back now if it had gotten deleted or corrupted or overwritten at a previous point in time. Now, I haven't really mentioned this too much here as we've talked about backup, but just another thing to keep in mind that's very important about backup, especially if you're using tape, is that it is a very good archival solution. Many organizations will back up to tape and then take them off-site to a storage facility of some type that's temperature and humidity controlled, and then they might be able to keep all the data on those tapes, you know, indefinitely. It could stay for, you know, dozens of years or a lifetime, for example. Most of the time, the idea there is that they will stay there perpetually. And then the only other thing that happens in companies, at least, is that they then have to be concerned about the compatibility of those tapes, because new types of hard drives come and go. And some companies actually run into problems because the tapes they have in archival storage, there's no tape drives made for those anymore. So then you have other challenges. But that's a little bit of a digression. Key thing to remember there, tape backups, archival is a very good purpose for that. Now, we've talked about Windows backup using NT backup. This is also available, by the way, as a command line item if you want to use scripts or batch files to work with that. However, this NT backup utility is only really available on previous versions of Windows before Windows Vista. Vista does not even have NT backup anymore, although Vista is part of the A+ exam objectives. So I want to show you how backup is done under Windows Vista, and also, by the way, Windows Server 2008 to some degree. They're not exactly the same, but they're similar. similar. If I go into System Tools and Backup Status and Configuration here, notice that I can choose Backup Files, and then it has a Set Automatic File Backup. And what they try to get you to do is to back up to a hard drive or CD or DVD. I don't really have anything besides the CD. Normally I try to back up to an external hard drive, and then I could just click on Next. I could also back up to the network, but that has some limitations, so I generally stay with a local media. And then you can specify what type of files you want. Do I want picture files, for example? And it will tell me JPEG, PNG files, and so forth. You can also choose additional files down here, and anything that's not in these other categories. And this is just kind of by category in terms of the backup solution. Then you schedule it. And then once I click Save Settings and Start Backup, it'll start to save the backup to the CD or the hard drive or the DVD, whatever it is that I have specified. Then if I want to restore the files, I just click here and start a similar wizard, only it goes in reverse. And then here we have a complete PC backup. Now I really, for me personally, never really use the backup files item. I don't think I've ever scheduled that. I always just use a complete PC backup, which cannot be scheduled unless you use a script and you schedule it as a scheduled task. I just use complete PC backup because it's useful for a bare metal restore. And with this, it'll back up the entire hard drive with the entire operating system on it. And that way later on, if the hard drive fails or whatever, I can then restore from this complete PC backup. It's also useful for recovering system state data. In this nugget, we addressed storage, and this was part 4, where we talked about troubleshooting. Remember, there's a lot of different things you can take a look at with troubleshooting. You might even just use the check disk command. We looked at it in an earlier nugget. But also, be sure to check the physical connections, and that nothing's come loose, especially on those serial ATA connections. And we also took a look at backup, which of course is a critical part of any storage solutions. You have to make sure that you have a good backup available, so that if anything goes wrong, you can quickly and easily restore that backup. And also, we took a look at the fact that NT backup is only available up through Windows XP and Windows Server 2003. With Windows Server 2008 and Windows Vista, as well as Windows 7, by the way, you'll have to use other methods because NT backup is no longer there, but in the interface, you can still use the backup utility. Also, by the way, I didn't mention this earlier, but with the backup utilities in more recent versions of Windows, the command line version of that is called WBadmin. In fact, let me just write that up there, WBadmin. This is actually a PowerShell script that you can run. And what this allows you to do is to all the same things, only from a command line. And that way you can schedule it as a task or something if you like. Well, I hope this has been informative for you, and I'd like to thank you for viewing.